I'll introduce you a little bit.
Okay, fine, do that, please.
So our last speaker for today is Mark, one of the co-inventors of IOTICS, who we're currently working with here at Sheffield, both in the Dynamics Research Group as well as the AMRC. And he has a very different perspective on digital twins than I do, at least. So I thought it'd be very important for him to come and at least talk to us about his idea of digital twins and his interpretation of users. So go ahead, Mark.
Right, hi, thank you, Matt, for the intro, and thanks everybody for having me. I do feel like I've dropped out of orbit into a completely different universe where you're talking about digital twins in a very different way from me. But if we just accept that I'm going to be the maverick for this afternoon and try and present a different perspective and try and explain what IOTICS is about, why we decided to build it, and then a little bit about how we're working with Sheffield on a particular project. Hope everybody can hear me clearly. If you want me to speak slower or whatever, then that's fine. I was hoping to show you a code level demo today, but of course that's the one that's gone wrong, but hopefully the rest of the demos will be work. So please bear with me. It was all working this morning. They all say that, don't they? Anyway, so let's start off up here. So the challenge with IOTICS is, what if we could overcome the fear of sharing? Because it seems that most people aren't prepared to share their data because they're just afraid. Various other different words they might use about security and that kind of stuff, but they just don't want to because they don't know what the consequences would be, or they don't know what the backlash would be, or all sorts of things, but they're basically scared. So if we think about all the things that exist in the real world, like, you know, transport and environment and weather and systems and APIs and all of that kind of stuff, what if we could put on top of all of those different things what I will call, for the purposes of this talk, the headless semantic layer? That's not my phrase. I read it in a Medium blog a couple of weeks ago, and I thought, wait a minute, that's actually not a bad way of talking about this kind of thing. Headless meaning there's no application on it on top. It is its own thing. It doesn't need an application. And the semantic bit being that I know that a bicycle is different from a scooter. They're very similar, but they are different. And one of my favorite examples is about tanks. If somebody says to you, I need some more tanks, and you go and get them tanks full of goldfish, they're probably going to be a bit upset if they're a 3-star general. So what if we had this headless semantic layer? Who would be the user? And this is something that's kind of really bugged me all the way from the beginning of IOTICS. And the beginning of IOTICS goes back to 2012, 2013. So it's, we're coming up for 10 years old, the idea anyway. And it's always been a real struggle for us because we've built the headless semantic layer and the users of it are always a bit weird. And I have been known to run around when we had an office at IOTICS shouting, IOTICS is not for people. So what I'm going to try and do then is today is to kind of tease out what the user means in these digital twin systems. But before we start, let's kind of set a few popular myths aside. This is what you think is true. I get my laser pointer, I can say there. You have a high value asset, and we've seen some nice robot arms today. So there's a nice robot arm. Maybe it tells you how hot it is, the pressure in its hydraulic couplings, and maybe it has a location on it. There's some kind of connectivity. That data goes into a database. There's an API that gets the data from the database. And as long as you know the asset ID of that thing, you can go and find its data and you can display it in an app. And everybody's happy. Well, are they? Because what we found in our work is sometimes the high value asset is a bit old. And it gets its temperatures and pressures in that way through some connectivity into a database, and there's an API for those, which you use the asset ID as the key. But the tracker, the GPS component of it, is an aftermarket add-on. So that has its own connectivity, it has its own database, it has its own API, and for which you need to know the tracker ID. And it gets worse if that high value asset is in some kind of building, then you might want to know the temperature, the pressure, and the location, something from the BMS data. You might want to know what the ambient temperature is, or how many people are in the room, or those kind of things, which the BMS might be giving you. That's got its own connectivity, that's got its own database, that's got its own API, and you need to know the building ID. And that gets even worse when you start having location-based contextualized data, like the weather near that location, or the air quality near that location, or maybe something like a crime geofence at that location. Now, your application has to keep track of 1, 2, 3 different IDs, all the different locations, and it's now looking at 6 separate APIs in order to form the picture of the world that it needs to know. And I'm not a big fan of APIs. Everybody thinks they're the way to save the world, but I don't agree. APIs have pretty dodgy documentation most of the time. What format does the data come back to me? Is it in XML? Is it CSV? Is it some kind of JSON? How do I identify the things in there, which asset ID or tracker ID? What's the unique key that I use? Do I need an API key? And there's a whole bunch of other things, like REST is not a standard. People make their own APIs up however they want. And it just gets more and more and more complicated. And now I'm going to ask you, who's the user? Now, I would argue in this situation that the user of this is the programmer, because it's the poor old programmer who has to deal with all of these different problems with the asset ID, the tracker ID, the building ID, and all the location-based ones, and all the different API formats, etc., etc., etc. That's the programmer's job, to work their way around that load of complexity, and all of that code ends up in the application, where I would say it has no place. And if we want to have autonomous agent systems, if we want the user of these things to be a computer, how on earth is a computer going to do that? No matter how clever they are at natural language processing, they won't be able to read API documentation. They won't be able to get an API key because they don't have an email address that somebody can email it to them. How are they going to do metaprogramming if they don't know the format of the data that's going to come back to them? So it's all a bit of a mess, really. So we decided to try and build something that would solve that problem. And what we decided to build was a digital twin ecosystem. So in the IOTICS world, everything is a twin. And when I mean everything, the twins of the asset, like you would expect, there's a twin of the building. There may be twins of the air quality sensors nearby the building. There may be twins of the weather forecast around by those twins. But there's also a twin of the application. Now, everything is a twin. Everything is driven by search. Well, if you want to be able to search for things unambiguously, you can't use natural language processing again. So in which case, everything has to be described by semantics. So in the IOTICS world, every twin has a bunch of RDF triples against it, which tell you about the twin that you've just got. And you can, as it's RDF, you can look up the definitions as well as the results. And everything is based on find and bind. So you should be able to say, I want to find some data from the asset, for example, and can I bind to it? And then I wish I'd invented this term, but hopefully you're aware of the FAIR data principle. So things should be findable, accessible, interoperable, and reusable. So at this point, I was hoping to run a demo. Let me just see if anything is disguised to that if it wants to work. I don't think it will, because I think I've got some weird DNS resolution problem at home. So gonna win. No. Okay, so that's not going to work. Okay, but I would, I might just show you what I mean though. Who's the user now? Okay, well, who's the user now should be a computer. So I was going to show you a demo. Oh, in a minute, not in a minute. Let's just talk through the slides first. Okay, so if we're going to virtualize everything in this new world, in this headless semantic layer that we were talking about, you've solved yourself a whole load of problems, but then you cause another. And I think some of these ones are true of everything we've talked about today. Like, what's the identity? Are you who you say you are? Can I trust you or your manufacturer? Is your data true? Is it really 20 Celsius like you say it is? And then the provenance is, does your data really come from you? Is it actually bound to that particular piece of hardware that I'm getting the data from? And I did these for some slides for Multos, the people who do some of that identity-based stuff. And we had this idea that you could be phished if you were in this this new virtualized world where something was pretending to be a fish and it wasn't. So the IOTICS is built around 3 principles. And the first one is the twin is in control of its own destiny. And that means that you can enable a twin to talk to another twin, but whether or not that twin chooses to share data with the other twin is completely in the control of the first one. You've got to try and mitigate against malicious, like denial of service attacks coming from malignant twins that have joined the ecosystem and are trying to attack other twins. So you want to be able to do that. You want to enable the digital twin ecosystem without revealing too much about yourself, without being denied of service by other twins, and also by protecting the underlying hardware or technology by using the twin. So if you attack the twin and the twin falls over, then fine, but it is only a twin. In which case, then any interaction, anything, please can I have your data, has to be brokered. And the other thing is about that is then you can also, if the application is brokered, you should be able to say no to the other party and say, I'm not prepared to share my data with you. Okay, all right, so far? I can't hear anybody, but I'll just throw that rhetorical question out there. So a very weird feeling of talking to the air at the moment. But, okay, so the first thing then is, can I find you? I don't know if anybody's familiar with the way that the RDF and ontologies work, but we have a visibility class, and twins can have a visibility, and at the moment they're just public or private. So you could say, I'm happy for other people to find this twin in the IOTICS space, and in this case it says I'm not happy for other people to find the things in my space, but I will be able to find it myself. So the first thing then, and then the second one is, can I follow you? And again, it's kind of difficult to do this one out of, virtually by me waving my arms around in a little tiny box. But this was the original one when we had a centralized registrar. We don't anymore. But basically the idea is you'd say, hey, central device, can you ask the producer of this data, is it all right for me to follow them? And they would say yes or no. And then the next time they shared, I would get the feed of data from that thing. If this came back as a NAC rather than a NAC, then I wouldn't be able to get the thing. And this at this point is when I was supposed to be doing a demo. Yes, so this bit here is about allow lists. Are you allowed to follow my twin? So what I'll do, in the absence of any of actual code working, rather annoyingly, I will just show you the code so you get an idea what I'm talking about. Give it a second while it boots up. Matt, are you there? Are there any sort of puzzled looking faces in the crowd, or are we all right so far?
Yeah, I think you're right.
I'm flying blind here.
Yeah, you're all good.
All right, bear with me a moment, because now it's going to have to download a new version of VS Code. And well, this is not my day, is it, really? Oh, I tested all of this stuff this morning before the thing as well. Oh, come on. Temporary failure in name resolution. Oh, we can't find update code visualstudio.com. Oh, for goodness sake.
Sounds like you're really having a bad DSS issue.
I am, aren't I? Blimey, I'd have to reboot the whole world, I think. Okay, anyway, let me just try source, Python, source, and okay. Right, okay. Can you see that?
Yes, it's very small.
Okay.
But
It's very small. Can I make it bigger? Is that better?
yeah, that's better.
Okay, so this is what an IOTICS application looks like. Where am I going to? Where's my? Can you see my cursor coming down here? Down. Sorry, I have to run in Nano because I can't get VS Code to work because of DNS resolution. Why? Never happened before. Anyway, the idea is this says I'm going to get myself an identity helper, and then I'm going to create myself a twin. There we go. So it says this is my publisher, and then I'm going to set the visibility of that twin to being public. And then I'm here going to, oh, okay, interesting. I was kind of hoping that would scroll when my cursor goes off. Oh, it really isn't my day today, is it? Oh, for goodness sake. No, I think it's because I've made it bigger. Okay. So here I can add properties append, you see? So I can add some RDF comments, and I can use a different ontology. This is schema.org serial number. I can add 1, 2, 3, 4, 5, 6. And that's now allows that to be searchable. With the public visibility and something like that, I can now, that will be found by another one. And what I'm setting at the moment is I'm allowing all hosts, which is all twins in other hosts, come and find me and do that. And then what I'm going to do then is go in a loop and share some feed data every 3 seconds, which was what was supposed to happen at this point with this excellent demo that you're all enjoying thoroughly. If I then show you the opposite side of that, what we would call a follower in our world, what this follower does is it will come down and it will go very similar sort of symmetrical kind of behavior, create myself a follower, and then I'm going to do this search here. So I'm going to follow by looking for the serial number according to the schema.org property 1, 2, 3, 4, 5, 6. So I'll find anybody who has that, and then I'll fire off that search. And that search will search the entire network of spaces, try and find the thing that I'm interested in. And then it gets down a little bit along here and it goes, I'm going to follow that feed. And when I get some data from it, follow this in the callback. So my excellent demo was to show you that one working with the feed sharing and then the feed being followed. And then in the other side of things, I could then go and change it to being not available. So I could still find it, but when I tried to do this subscribing thing here, it would then fail because it wasn't allowed to do things. So I've got 2 things there working for me, or 3 things already. I've virtualized. I can set my privacy to being visible or invisible, and I can bounce anybody who tries to find to me in real time. And I really don't think it's going to work, but let's have a try. There we go. It's going to go, oh, look, I'm starting up, and then it'll go DNS name resolution failure. There we go. Bang. Okay, and just to prove this, not just the IOTICS one, if I try and run VS Code, it will also fail, but never mind. It will go here trying to download and it will go, no, I can't find our Microsoft either. There we go. Failed. Good. Never work with children or animals or computers. Right, anyway, so that gets us to, can I find you? Can I follow you? And this is going to be my great code demo, which was great, obviously. And then the last piece of the puzzle of this one is who are you? The way that IOTICS works is based around the decentralized ID, which is a W3C standard. And then you can see here, this is my DID. And sorry, now my cat is going through the I wish I could have been with you guys. Would have been having a much more fun time. You can see up here, this is the DID. And you can see in here, it's got some interesting stuff. It's obviously got the public key of that thing. So I can verify if it signs anything, I can verify that it's coming from this thing, but down to those things about provenance and identity, and is it really you, those kind of questions. We'll talk about this authentication delegation of control in a minute as well, but the DID spec allows you to have these delegations. And if you want the user of these systems to be a computer, then it's really nice that it can look up this abstract identity and get the private key, the public key rather, from it. And this delegation of control means that if I'm a computer, only if I have that delegation of control can I change the twin. So if I'm going to update the twin to change its metadata to say I'm now blue rather than red, I better be sure that I'm the right authority to be able to do that kind of thing, because in this agent-based world, then you really need to know who's changing your data, who's sharing your feeds and those kind of things. So we use these DID spec, the delegation of control and the delegation of authentication. Oh goodness, my cat is now meowing. Right, so that's DID. Back to the principles. The principles part 2, metadata is more important than the API. This will label me as a complete maverick, but I don't think the APIs are correct, because all of the logic is either buried in the /this//the other, or it's buried somehow in the JSON of the thing, that the payload that you get back. I think that the metadata should be in RDF, which is the right standard for metadata. So each of our twins has a metadata plane and a data plane. So if I go back to the, can I just go back to the, if I go back to here, when I create my twin here, I'm saying it's a label of a publisher and it's got the serial number. But also when I start to create a feed, so create a feed and add some payload to it, then I can make the values of the feed described in semantics as well. So I'm saying this is the wind speed measured in meters per second, and that obo UO 0094 is actually the semantic definition of what meters per second means. And the floating point is to help you know what kind of thing. So whenever I follow this twin, I have access to all of this metadata. So I know what it is and I know what I'm getting. And using its DID, I can also check that it is who it says it is and it's coming from where it says it is. So you've got this nice symmetry. So whatever, if I say I'm Mark and I want your data, the twin itself can check back and say, are you really Mark? Are you really asking for my data? Should I say yes? And then when I ask the other twin, say, can you describe yourself? It tells me who it is, what data it can publish. And then it says, right, can I follow you? You look really interesting. Can I follow you? Like that. So imagine it almost like LinkedIn for things. Yeah, except it's not quite like LinkedIn and it's not centralized. And also there are no blue ticks on LinkedIn as far as I can tell. So you could actually masquerade as being Albert Einstein on LinkedIn. And how would anybody prove that you weren't? So this is one of the things that bugs me a lot about the way that we treat data in the industry. So we sort of start off by saying, oh, the data used to be in system silos because it was the data for that particular system. And that systemic view of data was okay, for when you had ERP systems and PLM systems and I don't know, documentation systems and all those kind of stuff. It was fine. You had all these different systems, and then people thought, oh, actually having all this data in these systems by system-based silos is bad. So we'll shove it all into a data warehouse and that will make things better. Or we'll virtualize it, or we'll have a data lake and we'll throw it all in a data lake. Or we might even have a mesh, which is, as far as I can tell, a lot of data lakes. And then you might say, well, actually, now I've got all this data in this messy, whatever it is, I need some kind of catalog in order to work out what data it is and where it is and where it is and where it isn't. And this is all fine, I guess, but what about the asset? What happened to the thing? Because I might end up with some data about my thing being in a PLM system, some of it being in an ERP system, and something else. Is it the same thing? And how do I know? And if I'm trying to answer a support call about that thing, how many different systems do I have to log into in order to get to that one asset? I call that asset smearing. So you've got this poor asset, which is now smeared all over the place. And it might be smeared into systemic silos. It might be smeared into data lake. It might be all sorts of things. And it's probably almost certainly going to be separate from its IoT data stream of I'm this hot, I'm this, and this particular location. So some way of bringing together the sort of static, quote unquote, metadata about the thing and the IoT streams about those things. And if you want, also a control interface about those things, so you can turn them on and turn them off, is really where IOTICS comes into its own. So in IOTICS world, we talk about this twin-to-twin interactions where there's RDF metadata for the twin itself, any feeds it has and any controls it might expose. The feeds are near real-time data streams and controls are actions, mutators, turn off, turn up, turn down. And the interactions, as we've seen, are brokered. And so you can see here, this twin says, oh, can you share me your metadata on the yellow plane? And it goes, yeah, okay, fine, this is what I am. And then it might say, well, all right, can I follow you? In which case the streaming data on the green plane will come across to this one as well. Now, very interesting listening to Siemens guys this afternoon and a couple of people this morning talking about simulations, because there's this piece in IOTICS called the agent, where in a simple example, all the agent does is read, let's say it could read the hardware of the asset. Okay, so tell me your temperature. Okay, I know the temperature, so I can update the twin. I'm this hot, maybe share it every 10 minutes saying I'm this hot. That's a very simple agent here. This far side agent says, oh, I found this really interesting thing about temperatures. I'm following the feed, and my asset in my case is the database. I can just shove the data in a database. What if there's no asset? What if this bit doesn't exist? Then this agent here is purely code, which sounds to me a bit like, unless I got my wrong end of the stick, what the Siemens guys were talking about by the executable digital twin. This could be a simulacrum of the twin, of the wing, or whatever it was, which other people can use for their testing. So I can have a real thing over here, which is going, oh, actually, oh, I found the simulator of the aircraft structure or whatever, and I'm going to fire it some messages and see what it responds. Oh, okay, it's responded with these messages. Okay, it's behaving like a real thing, even though there's actually no asset behind it. Okay, so it's twin-to-twin interactions. Twin metadata, here we are. This is what we've said is RDF. So here's the DID. At the top, it says I'm a digital twin, and then it tells me when it was created, there's some labels and some comments in different languages, and then it might have some other metadata about birthdays. I don't know. This is our test data, so it's all sort of messing around. And then it has a geolocation as well, so you can find them in there. And the advertises piece here, this is the UID of the feed that the twin is showing. So then that will link off to another thing which has the feed, and then inside the feed will be the individual values like the meters per second, those kind of things before. building blocks number 2. So if the twins exist, well, where do they exist? So we have what the concept of an IOTIC space. So we normally draw them as circles. And this is your one, let's say, and I'm happy to say all of these green twins are mine. These maybe all be private. These yellow ones are for public consumption. Maybe that gray one is as well. But these are all mine. So if I search in here, I find all of these things. And then that's fine. And that's would almost have solved the problem that Matt has with Liverpool University and everything. We could have done it that way, but there's a better way of doing it, in which case you get to principles number 3. There's no need for a middle. So IOTICS is a decentralized network of spaces. So remember, these green ones were private and the yellow ones were public. If I search here using my semantic search like I showed you a bit earlier, I can find these ones and the yellow ones because they're all mine. And then I send that search request over to the network and it says, I'm going to search only the yellow ones, the ones which are public, and I'm going to send them back to you so you know what you've got. So you have this public outward facing API on here, which you talk to, and then there's a space-to-space API inside across a decentralized hash table. So hopefully we might be able to do a demo now. I'm going to try, for some reason, not that one. Okay, we're being brave here. I am in Ganymede space, which is a general space that we use for testing. If I put in here London, okay, did you see the strange order that the spots arrived on the map? Well, that's because the search was federated. It said, go away to all those different spaces in IOTICS and find me things which say they're in London. And it's come back with lots of different kinds of digital twins. It's got lots of bike points. These are the Santander bike points. This is rolling stock model. This is things which are trains on the Porterbrook, who are a train operating company. There's some Northern Water customers. I'm not quite sure what they're doing in London. There's railway stations, there's weather stations, there's weather forecasts and things like that. So what's this one here? This could be a weather forecast. There we go. So they have their data in there. And if I go into the Explorer and I type bike, hopefully this will then find me, give it a minute. See, what I don't understand, Matt, just out of interest, is why the browser is working, but my Linux is not working. It's just really mad. So if I pick on this bike point over here, and I pick up its details, it's going to get the properties, you know, it's a decentralized system. So it's getting these different properties about that bike. And it says, here's the bike occupancy, which was updated just now. So it says the number of available bikes. It knows it's just a dimensionless number, so it can show me. It knows this was the time, the total docs. So that's picking up the TfL bike data from their own API, but representing it as a digital twin, which is findable in with all these other different things that are already in IOTICS as well, using the semantics to be able to distinguish them what they are. Right. Let's go back to our. Okay. So we've got all the building blocks now, and we had all of the, so we've got all the principles. Twin is in control is in destiny. Metadata is more important than the API. There's no need for a middle. And the building blocks are twins, spaces, and networks of spaces. If you start to do this, then you end up with a bit of a semantic problem as well. And I normally use this example because in America, people say cell phone, and in the Europe and the UK, we say mobile phone. So you've got a choice, really. You could say, let's let everybody say what they say, you could say everybody says cell phone, so one standard wins. Or you could say, or we want to make a new standard and say everybody has to say portable communications device, in which case you end up with this new compromise that nobody really likes. What we think in IOTICS is that you should have standards for domains that interoperate, because if you're aware of the semantic web, you should be aware of our same as, when you can say US cell phone, our same as EU mobile, and then you can resolve all those conflicts later. And it's not, this is the hard way to do it, but we think it's the only way that will have any legs, because you're not going to get everybody to agree that the Americans are right and we should say cell phone. And we're definitely not going to need everybody to going to say, oh, actually, we need a third standard now when we all say portable comms device, because nobody wants to say that either. There is a thing in the semantics world called the open world assumption, which is basically frames that if I don't know something, it means I don't know it. In the closed world assumption, if I don't know something, it's false. And the nice thing about having these data ecosystems is you say, well, I don't know something, maybe somebody else does. So I can go and find it and find out what's going on. And hopefully they'll share it with me. Oh, well, we've seen that federated search the IOTIC way. So we've seen the London map, and that's based around, I don't know, something like 20 or 30 publicly available open data APIs, all of which have their own format, are owned by different people, have all those problems that I outlined at the beginning. We've now normalized them all as RDF and digital twins, so you can now search for them and find out what they are unambiguously. Here's one in action. The Shape UK Data Ecosystem project is now finished, but it was the Innovate UK project based around trying to decarbonize Portsmouth International Port. And the way they chose to do it was to base around these Cox people who have a really clever idea of using old existing diesel engines, but injecting hydrogen into the airstream and running them on a mix of diesel and hydrogen. And they will happily accept that, knowing that you're not going to go, oh, we're never going to use diesel again to fall off a cliff. You're going to gradually ramp diesel out and then hopefully ramp hydrogen in. But as soon as you start thinking, oh, wait a minute, I need hydrogen for fuel for these boats, where does the hydrogen come from? So you have the people who own the electrolyzer, these N-gas people. The Portsmouth International Port have solar panels which power this thing. There are people who store it and distribute it as well. There are people who want to analyze things. There are people who want to measure the environmental impact, which are these B4 people. And there are people who want to measure the air quality, and they can see whether some of these things are having any effect on the world. So we can hopefully whiz to, notice this is a separate space. That was Ganymede, and this one is Portsmouth. And you can see here, this is the view in Portsmouth Port as available to the Portsmouth Port IOTIC space. So if we go back to our thing, that's that view of the world. Yeah, so anything in these ones which is private won't show on this one. So here we are. These green ones are boats. This comes from the marine information system, so we know where all the boats are. And if we zoom in a bit here, we should see there's only one boat because it was only a small project, but there's this boat here. And I can look at that boat and it will tell me the metadata about that boat. So it tells me all these things. It tells me a heartbeat, fuel consumption, and then I can, well, yeah, so it's got this, yeah, okay. Oh, great. It's not the day for demos today, is it? Tra-la-la. Anyway, that should show me what the things are. I really am struggling. Maybe it's because I'm running Zoom and everything as well. Let's go back out again. Try again. Ah, there we go. Yeah, probably just timed out. So yeah, so I want to look at the fuel consumption. It says, oh, fuel consumption, I can show you diesel consumption, I can show you hydrogen consumption. And then you can basically just say, oh, okay, I'm interested in those. Can I have them? and start to follow those data feeds from the things. Okay. So that's the shape data ecosystem. Then, so I don't know whether I've lost the audience. Matt, help me out here. What we're working towards here, I hope you're beginning to realize, is that I'm showing you things as a person, using UIs and those kind of things, but you might be scratching your head saying, I thought this was supposed to be the headless semantic layer. What I'm hoping to be able to show you is that if I can do it this way as a person, you could meta-program an application that could do it itself. It should be able to be sufficiently unambiguous and detailed enough so that you can start to write applications which respond to the semantics of the so-called data-centric applications, or the data-centric revolution, as advocated by Dave McComb and Semantic Arts and those kind of people. Well, if I do that, I should be able to do things via ontologies and things like that. And we've written our portal, and I would say this is baby steps, but at least we can have a go. If I go back to Ganymede here, and I go into the Explorer, and I search for customer. What I'm going to try and show you here is that the UI responds to the semantics of the data that it's received. So if I come in here and I go in here, this is a twin of a customer. It's found that customer there. If I go into their details page here, yeah, I've got all these different things, these properties that a customer could have. But if I want to refine those results in here, I want to say add a rule to that. And here I want to talk about vulnerable. So is vulnerable, for example. I know in is vulnerable sorry, beg my pardon, got the wrong thing. Is vulnerable. Yeah, okay, so is vulnerable, it knows is Boolean, so it can say yes or no. So if I say yes on this one, and I add that rule, and I add another rule here, which is the vulnerability type. That vulnerability type has come from the ontology about vulnerabilities, so I can pick up one of these things in there. So I can now search for unambiguously using only the data that I know from describing the twin. I can now search unambiguously things. I actually don't know whether this person, there we go. So I've now found people who are vulnerable and have the developmental condition as their vulnerability type. So without knowing any of that in advance, the UI is able to use the metadata in order to work out what it can search for and the values that it can use. And then if I apply those filters, I only get the people who satisfy that condition. So I've now found data in an abstract way and in unambiguously defined data, so I can now find it. Now I can go and ask to bind to that data and work out, what's happening to that vulnerable person. Maybe they've got a heart rate monitor, or maybe they've got some stuff in their house which is sharing whether they've opened their back door or not, that kind of thing. We can do the same. I'm not going to bother with this, but we can use the same idea. When you you can use the ontologies to create models for twins, and then you can show them going on now. Okay, back to stuff that you might recognize. Thank you, David, whose voice I think I heard earlier. We have done some work with Matt and his team around the test cases for this Hawk trainer. It's not using the full power of IOTICS, but we've really enjoyed working with these guys because they've helped us a lot with semantics. Basic idea is this, is that they run loads and loads and loads of test cases, and when somebody wants them, like I think somebody said earlier today, they email them to each other. There's no real metadata about these test cases. So in the email, just says, "Oh, this was the one I ran last Tuesday." And one of the quotes I really love about it was they said, "We lose friends over this." They find your email, they'd spend ages and ages running their simulations against this test case, and then they go, "Oh no, sorry, that wasn't last Tuesday, that was Tuesday before that." Great, thanks. I'll waste all that time. So the idea is that you collected the data and you shove it into their own internal databases, but they've wrote a digital twin of the actual test case itself. And then you can have digital twins of the sensors on the airframe as well. And then you can see how those digital twins would come out in our own UI with the metadata properties and the values of them there, which would be pretty cool even on its own. Oh yes, this was did great work actually. I'm very proud of our guys and your guys for doing this. You know, what do you mean by a sign swept test case? Okay, so we'll actually define that. We've now got a defined vocabulary of stuffs that we can talk about. When you talk about random bursts and continuous randoms, we know we're talking in the same language because we've defined it. We've got fixed vocabulary. We've written an ontology, so we know what we're talking about. And now we can start to link up with sort of Swansea and with Liverpool, opening the data in the Sheffield space so that these guys can find it and then they can ask to share it. And now we're building a, if I can find the twin and follow it method, I can then go into this database here and get the data from it because I've forged the twin-to-twin interaction in the space. We haven't quite got there yet, but that's what we call the data bypass pattern. So given that you can talk to the twin, it means you have access to his historical data as well. Right. Are we there? Oh, that was going to be a video. I don't think we need a video. Right. So then, in the end, who is the user? Is it the people? Is it the programmers? Or could it be a computer? Could it be an autonomous agent? Is it possible that an autonomous agent could use this headless semantic layer and find and bind to the data that it wanted autonomously? And then if that's the case, what is the user experience for an autonomous agent? Which is the first question I ask anybody who comes to IOTICS and wants to talk about the UI. Because I'm horrible. So there's a couple of things before we close, but I want to just let's pause here, Matt, and see if there's any questions or if anybody's frothing at the mouth in the auditorium, or they're just thinking that I've gone to the wrong conference.
No, you're definitely in the right place, but yeah, David has a question.
Hi Mark, David here. Thanks for that. So just following up, my question links nicely to your last statement, because in some of the earlier slides you had twins interacting with agents and possibly interacting with physical assets or not. You made the point that maybe there's not a physical asset there. In your terminology just here, you said autonomous agent rather than just agent. Now,
yeah, okay. Well, that's probably more or less
between an autonomous agent and an agent as you defined it earlier, or could you comment on what you're meaning there?
Okay, this slide, yeah.
Yeah, that's right. So that agent in that context, I think you described well. I'll let you describe it again.
Well, it's really about what we can do now as opposed to where we would like to be. Yeah. Me running around IOTICS shouting IOTICS is not for people is because in my head I would like this to be autonomous. What I could say at the moment is I don't think we're there. In some of these things, the behavior of these agents is very prescribed, as in I read the hardware and I share it via the twin. There's nothing particularly autonomous in that behavior, is it? But what if this was an AI? Yeah, what if this was something that was programmed to find sources of data, do something with it, make a prediction or something like that. And then via the control interface to other twins, it could orchestrate behaviors across, or even across geographies or across enterprise boundaries and those kind of things. Then I think we're working more towards what I would call an autonomous agent. But it's always our, it's always our kind of final visionary goal, is that you should be able to have autonomous agent systems that use the headless semantic layer to work out what the hell is going on. Yeah, so it's really, in terms of this presentation, it was more of a slip of the tongue in that I would normally just conflate agent and autonomous agents. But what I've hopefully shown you is that the bare bones are there, that you could actually program autonomous behavior. The reality of it is we're not there yet, I think is probably the case. Does that answer your question, David? Sorry.
Yeah, I think so. I mean, so just following on from that, my other comment was that myself and Matt and quite a lot of, I guess, others that we've been talking to have been thinking a little bit about, users, because I think users and defining users is not as obvious. And I think one of your points is that it's not as obvious as people think it is. And so I think what myself and Matt and others have been thinking about is that you should define a sort of hierarchy of users and what those users' specific roles are, and therefore what interactions and information they need from the digital twin, either ecosystem or in our terminology, just from the digital twin.
Yeah, well, fine. Yes, so again, it's bare bones versus where we would like to be. If you imagine that each of these twins here is described semantically, and a part of that semantics could be a role. So this one goes to this other twin and says, hey, I'd like to follow your data. Is that all right? And this one can look at it, describe this one back and say, what's your role? And it said, oh, okay, you've got this role of a manager. Right, yes, okay, I'm allowed to share with managers. I'll share with you. But you're not, we have the mechanism. Well, if I managed to run my code-based demo, you would have seen at least the can I bind to you or not working via semantics. And as IOTICS is semantics from top to bottom, then you should be able to add semantics to the data from the metadata of the twins, which would allow that role-based access to work, or what actually now is being called ontology-based access.
I think that's, so I think that's part of it. But it's not just the information that's available. It's the it's the format and the level of the information. The classic example is, because a lot of what you're describing is this kind of several intertwined things, but the other things that we've talked about are automation of processes and decision support for users or autonomous agents, right? So the autonomous agent might be able to take a decision, and so if it's a human or a hierarchy of humans, you've got some information at a relatively what should we say, technical level. That might be great for the specialist engineer or programmer or developer, but it's not very helpful to the senior manager who hasn't looked at technical information for 40 years, not 40 years, 20 years, but has to make a decision about whether the aircraft can fly or the wind turbine has to go into maintenance, which costs millions and millions of pounds, right? That's what they want to know the information at different resolutions, or a different, kind of summation or summary of the information compared to the technical person. Do you see what I mean? So the hierarchy is who the people are, but it's how the information is given to them, and they have to then make decisions at different levels in the organisation. The developer has to make a decision about how to find a bug in the code, but the CEO has to make a decision which affects whether the organisation is going to exist in a year's time. Do you see what
I see what you're saying. The at the granular layer of twin to twin, I don't think that second role is important. But we talk in IOTICS about outside in and inside out use cases. So an inside out use case is I'm a twin of a connected autonomous vehicle, and I've come up to a junction and I want to talk to the junction. That's just purely twin to twin stuff. if you can imagine an outside-in view of the world where you're actually using the decentralized graph to work out what data is, you want to know how many junctions are currently have autonomous vehicles at them, and you should be able to work that out by reading the decentralized graph, and you'll get the aggregated data from that. You want to know how many twins of this, or to answer your decision support thing, well, you write a decision support application that sits on top of the headless layer, gets its data from it, and it maybe even publishes data back into the layer as digital twins of the decisions. And you can have digital twins of the people who are the human in the loop saying, oh, I've received all this information, this is my decision. And that gets shoved out on their feed saying, I've made this decision. And then things can autonomously react to that decision. What I don't like is data coming out of that headless semantic layer and it's being lost. You know, it's just like, oh, I've just shoved it in this database here, or I put it onto a dashboard for somebody to look at. It's now gone. It's no longer any use to the big ecosystem of things. Hopefully, I'm not fudging the answer to that question.
Yeah, no, okay. But I think what you're saying there is that those sort of processes would sit above on top of the headless.
Yeah. So if you go back through here, wherever it is, yeah. So the headless semantic layer has got two sets of properties really. It's got all of the metadata of everything underneath it, which you could then aggregate or use graph database queries to work out, oh, this belongs to them, belongs to this, belongs as part of that kind of thing, you know. Or you might be able to say, count me how many of the things which exhibit this property. You know, you can do that across all of that stuff as well as saying, oh, actually, there's a tree there. Can you tell me the health of that tree using satellite imagery, for example? You know, that's are you talking to the individual cyclist, or are you talking to cyclists as a category? I suppose opinion.
Okay, so Mark, we just lost you for a second there, but I think I captured most of what you said there.
Yeah, you should be able to do both. Are you talking to an individual cyclist, or are you talking to cyclists as a category?
Yeah.
So given this, you should be able to do both. You know, how fast are you going, or how fast are you going compared to the average speed of cyclists over the last week? No, we can't. That's a ridiculously hard query to do if you have it like this. You're really well, Nissan and Ford, you wouldn't want your same data to be shoved in the same database so you could do that query. You're just not going to want to do that. So it has to be decentralized, and it makes that kind of query really, really, really hard. But I think it's possible. It's just really hard.
Okay, thanks, Mark.
Any more for any more?
Hi, Mark. Oh, sorry. Is there anyone else?
On you go, Marco.
Go ahead, Doug. Fine.
Doug, talk to me, Doug. I've
Sure.
not met you before. I know Marco already.
Hey, so I think that the stuff that you guys are doing at IOTICS sounds super interesting. And the way that you're looking at connecting all these digital twins is really interesting. You, when we're looking at the VR user interfaces, you mentioned latency then. And I was just wondering if that's a consideration here when you've got certain digital twins working off of data feeds from the other ones. Is there a way that you can, if I have a digital twin, how can I evaluate how recent that data that I'm getting from other digital twins is?
All of the feed shares are timestamped, so you know at least at the time that the system recorded it. I'm being very careful what I say here because it may or may not be the right time, but at least you know if it's 5 minutes old, it's 5 minutes old. Yeah. Do you remember when you showed you the bike set? This was a minute ago or something like that. So all of the data shares are timestamped, so we know. But then that does then say what is, you get into the whole kind of philosophical what is time thing. But my rule of thumb is if you want real time, low latency, don't put a network in the middle. And by definition, IOTICS is networked. So we can't do that low latency, high throughput bit, and we've never really tried because I just don't think we'd be able to. Just imagine if you had like 100,000 sensors, like like Matt's got, who record data. They need specialist hardware in order to capture the data at the speed that it needs to be done. They're going to put a bit of wire between the two of them. They're not going to put a network in the middle there, are they? So yeah, good question. Again, it's like, well, that's not the right use case for us. But if you've got that and you can look at that data at that speed and make some, maybe say aggregate over the last minute and say, actually, the average is this, you could share that. And that might be useful for people who don't really care about the really super granular nature of it. And maybe they can come back and get the granular data later. But just for kind of, near real-time monitoring, you don't need those throughputs, like, was it drill rigs on oil wells and stuff like that? They produce gigabytes of data, in a minute, and there's no way you can share that. You'd swamp the whole internet if you tried to.
Okay, so a quick follow-up then. If I want to connect to another digital twin, in this case, is there a way for digital twins that are connecting to my one to see kind of how often I publish data or the frequency with published data?
So again, it's one of those not yet answers. Thank you, Doug. I hope there's some other people from IOTICS on this call, because I'm always banging on about this, because you can do it. There's semantics which tells you intervals. Yeah. So I want to know, do you publish this once a minute, once a second, once an hour, once a week, on demand? Those kind of things. I need to know that when I'm following you, because otherwise I'll be sitting there expecting some data and I'm not getting it. The old earthquake sensor is my favorite example, because earthquakes don't happen very often. So you've got this earthquake sensor sitting there going, yeah, I can tell you when there's an earthquake, and you follow it and you go, are there any earthquakes? No, Jerry, no earthquakes. And then you wait 10 years and it's like, there's an earthquake. But it would be nice if you knew that it published roughly every 10 years, would be fine. Yeah. But yes, I think we have semantics on the feeds. You can describe the feed and you could put the frequency of sharing in there. So you can say, actually, these ones are more frequent than those ones. I'll follow those ones and not those ones. Okay. Yeah. It allows the a lot of data. Sorry, I'm getting all agitated now. But a lot of data, people go, I'm going to shove all this data in a database without thinking about how much pain it is on the far side to interpret the data that they've shoved in there. They go, all right, now I've done my job. All the data's in the database. Go fill your boots. I'm sure you'll be fine. And they're not trying to work out how difficult it is for the far end. Now, I have this thing called the IKEA compromise, where the IKEA could send you a bookcase. Yeah, you've bought a bookcase. They could send you the whole bookcase and go, plonk, there you go, there's a bookcase. Or on the other end of the spectrum, they could send you a tree and a saw and say, okay, you can work it out yourself. You can saw the tree up and make a bookcase yourself. What they choose to do is do a reasonable amount of work, pack it up in a way that's packaged so that you can then do it yourself at the end. And I think there's a lot of people who are very much in the tree and saw categories, and you have to work it all out yourself. I know Marco will complain. He'll say raw data is the best, but how raw and removing outliers is heresy. Well, okay, yes, but maybe have two feeds then. Maybe have a raw feed and a processed feed, and let people know via the semantics which one they're getting. Hopefully,
thank you.
Okay.
Yeah.
Marco, you want to talk to me about raw feeds, or you're going to talk to me about something?
No raw feeds. I think that's for another day. But I'm interested in your talk, and thanks for giving it. And about this, perhaps linked to David's point, these computers being users, and having these unambiguous queries that can make use of your work. I'm just wondering, like, what is your vision? I mean, isn't that I find it like kind of scary to see that these things can go on its own, without user interaction, without humans. It's just, you know, for privacy concerns, and you see that you can tracking people, you could track things so easily. Isn't there like, I guess what I'm asking, what's the vision? Why you think it's so important to achieve?
Oh, wow. Okay. Well, think about the rail network as an example. Yeah. At the moment, the rail network is run on post-it notes and emails and spreadsheets. And I've been to the Swindon Network Operating Center, and there's something like 200 people in the big room, and they've all got screens and they've all got stuff like that. And they're all given the information that they're given, they're making human-based decisions on these things. Well, is that going to be sustainable if we had, I don't know, swarms of delivery drones delivering packages for Amazon? Those kind of behaviors where it's too complex for the human mind to comprehend. And I'm not saying I want entirely autonomous systems. You know, I think there's a place for them, but definitely not when it's, you know, if something goes wrong, it's safety critical. But human in the loop systems where the data's more decision support data rather than the raw data of these things. And I've seen nice side-by-side stuff, sort of simulated environments where there's a set of recommendations from the machine learning that says, oh, I think you should do this. One of them was about heating systems in hospitals. You know, you've got this set of wind conditions, this many people in the hospital, and the temperature is this and the heating is doing that. It says, I recommend actually you turn the heating off in those situations. They recommend it to the person, and the person makes a decision. What they were finding was that the people weren't accepting what the AI was telling them, and they were making their own decisions, and they were worse at it than the AI was. So they're actually wasting money because they're putting humans in the loop of a system where you didn't need to have humans in the loop, because the machines are now better at it than the humans. Now, I definitely wouldn't do that if it was my granny in a care home. That then I wouldn't want a computer in that loop. But in, you know, should I turn the heating down in a big hotel, for example? Why put a human in that loop? You know, we don't have people who run the elevators in in department stores anymore, do they? And they used to have those. You know, these are things that I think increasingly will be driven by ML, and the better described the data is, the less ambiguous it is, the better.
Sure. Yeah. That makes a lot of sense.
I don't want to be Skycorp, you know, whatever it is in the Terminator movies, and I'm not advocating for that. But there is a time and a place for each of those things.
Yes. Thanks. I think that answered my question. Thank you.
Hello, Mark. Mattia here. Thanks a lot for your talk. It was very interesting.
Can't hear you. Hello.
Can you hear me?
Not really. Can you talk more closely into the microphone, please?
Yeah, I'm also biting, almost biting the microphone. So.
So, okay, fine. Let's go with it.
Yeah, maybe here is better. Yeah, thanks a lot for your talk. It was super interesting. I had one question about the decentralized ID, the decentralized identification.
Oh, yeah.
Maybe I didn't quite grasp it correctly, but my question is, if a twin has to identify the other twin, right, at a certain point, or let's say you have to assign permissions on sharing certain type of data, as a human, to is there the need to be like a human interaction there that let's say assign the permissions on every scenario, or yeah?
Well, it's the stage where we haven't had to have that problem so far. We've kind of broad brushed it at the moment, where in these ecosystems, if we talk about this one, for example, these people in NGAS, for example, were only prepared to share data with the international port. So humans set up the permissions so that this orange one could talk to the blue one. Yeah, there's an allow list. So this one would say, can I follow your data? And the rules on this one would say yes or no. But if these people here would come in, they would definitely say no. Yes. And you can see if we go back to the code example here, you can add the semantic properties to your twin here, which would, even at a twin level, would say who's allowed to come and talk to me, and who I will respond to or not. So again, it's the mechanisms are there. At the moment, we've only really used the broad brush ones, which was basically like this organization is happy to talk to that organization, but not this one.
Yeah,
Did that answer?
Is there a way maybe, yeah, that answers completely. Is there a way maybe in the future to automate also the permissions, let's say, more in depth? Maybe you want to talk to some organizations, but only share something specific, let's say, not open.
Yeah, yes. Okay, so yes, in the future, not at the moment. It's a bit binary at the moment. It's like I'm private, I'm public, and here's my metadata that if I'm public, everybody can see. Yeah. Having restricted access to the metadata part is interesting technically, because the semantic databases aren't great at doing that fine-grained permissions. You know, these triples are allowed to be seen by these people, but not those people. And also, if you wanted to say, can you sign your metadata to prove that it was you that made that metadata change? There's only just a W3C standard for being able to sign metadata at the moment as well. So this is quite cutting edge, some of this stuff. Some of those problems just haven't been solved yet, but they're in our roadmap, and that's a very, very good question. So, well, when I first designed IOTICS, I had the concept of hidden metadata. So when you broker the interaction with me, I could say, oh, and now I trust you. Now I can show you this stuff as well. And I used a separate graph in the semantics to do that. The semantic people tell you not to do it that way. So we do have multiple graphs now, so we can sort of protect it, but in the way of, if you get down to the many-to-many problem of which triples go to which people, the actual matrix in the middle, which decides which one, becomes unfeasibly large to allow these or not allow those. Tough problem, that one. The other way around it, though, is to have the hi-fi, lo-fi things, though. So you say, here's a public twin which shares every hour. It's got limited amount of metadata on it and stuff like that. Anybody can have it. I don't care. But for internal purposes, there's one with a lot more metadata and it shares much more frequently. This is a private one that we can all have a look at. It's fine. You can have more than one twin of the same thing. I have no problem with that. You can have it even in a separate space if you want to do. So there are ways around it, but they're a bit application level ways around it rather than system ways around it.
Okay, thanks, Mark. Any other questions people have?
Just drop one in chat, Mark. What about having ecosystems within other ecosystems? Does that help solve that problem, or is everything standalone at the moment?
Sorry, I'm really struggling again. So somebody either relay that question or stand where the speakers don't get to the mic.
Better? I'm literally using the microphone.
I'm sorry, please say the question again.
It's in chat. Look at chat, Mark.
Wait a minute. Okay, look at chat. Sorry, just trying to find Zoom. Anyway, where's the Zoom gone?
Yeah, the general question was, as a system or the ecology of spaces or spaces of spaces.
Oh, ecosystems and ecosystems. All right, I'll show you our vision slide if I can find it. Just bear with me 1 second. This is how we think it might work. But yes, ecosystems of ecosystems. Why not? You know, we're making this stuff up as we go along, as you probably worked that out. But we don't think there is anything like this. If you know of anything like IOTICS, please let me know, because I'd like to talk to them and work out how they think they could work. So this is how we think it might work. What we've built at the moment is this pink one. That's the public mesh where you've seen the Transport for London and the weather and the air quality and yada, 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 loads and loads of different things from lots of different places. We've built this one as well, like a private one with train operating companies and UK rail networks and those kind of things. They have their own one. And the way we imagine it might work is if you had gateways between the networks. So if this one wanted to know about the weather, for example, they could issue a search out through the gateway to this space, find the network from Met Office, and then start following it back through the gateways, in which case the Met Office would never find them, but they could search out. Is that what you meant, or did you mean actually having another one inside this one? But ecosystems loosely connected to other ecosystems, I think, is a very natural topography, isn't it? If you think about your own friends, you've got, in my case, I've got cycling friends, I've got music friends, I've got tennis friends. There's things I like to do, and very occasionally one will cross over. I've a cycling friend who plays tennis, or a musical friend who likes cycling. You know, those kind of things. But most of the cases, you like cycling people talk to the other cycling people, and musical people talk about music. Yeah, that gives you that topology. It's a very natural way of these kind of networks self-organizing.
Yeah, I mean, the thumbs up. So yeah, that's what he was asking about.
Okay, good. Yeah, we thought about it. We haven't built the gateway yet, but it's on the roadmap. I'll have to say that. It's on the roadmap. It's 10 years away.
Long roadmap.
Yeah. Anyway, it's in the vision slide, so one day we'll build it.
Yeah. Any other questions that people had? Okay, so nothing in the room. Anyone online?
Oh.
Well, it is 5 o'clock, so that works out kind of.
Yeah, that's right. You've got pub in the schedule. I'm not going to stand between people in the pub.
That's very good.
Can I just say thank you very much for having me, Matt? Thanks for inviting us to come and chat. And I hope we weren't too left field for what looked like an awful lot of very, very clever simulations and and modeling and that kind of stuff.
Oh, thank you very much, Mark. Let's give him another round of applause.